Something goes wrong in the aging brain that most people do not notice until it is already advanced. The system responsible for cleaning cellular waste begins to slow. The networks that form new connections grow sluggish. Blood vessels supplying oxygen and nutrients lose their elasticity. These changes do not happen overnight. They accumulate across years, often starting in a person's 50s, becoming measurable by the time they reach 60. I am Dr. Warren Hung. I am a medical doctor, and I present the channel We Care Health. I spend my time explaining how the body actually works so that people can make decisions based on physiology rather than marketing. Today, I want to answer a specific question. Many people over 60 want to know what actually reverses brain aging, not slows it, not masks it, but reverses measurable aspects of it. They want to know what works faster than the alternatives they have already tried. This video will give you that answer. But first, you need to understand what is actually breaking down. The brain produces metabolic waste every moment. Dead cells, misfolded proteins, inflammatory byproducts. In youth, the brain clears this waste efficiently through a network called the glymphatic system. Think of it as the brain's drainage infrastructure. Cerebrospinal fluid washes through brain tissue during sleep, carrying waste out through specialized channels. By age 60, this clearance slows by approximately 30 to 40% in most people. The waste accumulates. This is not theory. Researchers at the University of Rochester, led by Dr. Maiken Nedergaard, demonstrated this decline in glymphatic function using rodent models and confirmed parallel reductions in human cerebrospinal fluid dynamics through advanced imaging studies published in 2012 and subsequent years. At the same time, the brain's ability to rewire itself, neuroplasticity, diminishes. This depends heavily on a protein called brain-derived neurotrophic factor, or BDNF. BDNF acts like fertilizer for neurons. It supports the growth of new connections and the survival of existing ones. BDNF levels naturally decline with age. The hippocampus, the brain region critical for memory formation, becomes particularly vulnerable to this reduction. Dr. Carl Kottman at the University of California, Irvine, established through longitudinal studies that BDNF availability correlates directly with cognitive preservation in aging populations. The vascular system compounds these problems. Cerebral blood flow decreases with age due to arterial stiffening and endothelial dysfunction. Less blood means less oxygen, less glucose, and fewer building blocks for maintenance. The brain receives what it needs, but not what it needs to thrive. Dr. Rong Zhang at the University of Texas Southwestern Medical Center demonstrated in controlled trials that reduced cerebral perfusion predicts cognitive decline independently of other risk factors. These three systems, waste clearance, plasticity chemistry, and blood delivery, operate as an integrated maintenance network. When one falters, the others strain. When all three decline, the brain ages visibly on scans. Ventricles enlarge, white matter develops small lesions, the hippocampus shrinks. These are structural changes, not just feelings of forgetfulness. Here is what matters for this video. These declines are not entirely fixed. The brain retains capacity for adaptation throughout life, but adaptation requires specific stimuli. General activity helps marginally. Targeted interventions help substantially. The question is not whether reversal is possible. The question is what generates the fastest, most measurable reversal for people over 60. Most people try the obvious approaches first. They do crossword puzzles. They take fish oil. They walk 30 minutes daily. These are not wrong. They are simply insufficient for the structural changes required. To understand why, and to identify what actually works faster, we need to examine what each of these interventions actually does to the three systems I just described. But before we compare solutions, we must look at why the common approaches fall short and what physiological criteria any effective intervention must actually meet. Most people over 60 who want to protect their brains start with three things: mental exercises, nutritional supplements, and moderate physical activity. These choices are logical. They are accessible. They receive widespread recommendation. But to understand why they do not reverse brain aging quickly, or sometimes at all, we need to examine what they actually do to the biological systems we discussed. Let us start with cognitive training, crossword puzzles, Sudoku, brain training applications. These activities engage specific neural circuits. They require working memory, pattern recognition, and sometimes speed of processing. When you practice them, you get better at them. This is learning. Learning always involves some degree of synaptic change. However, the brain adapts specifically to what you train. Dr. Adrian Owen, then at the University of Cambridge, led a landmark study published in 2011 involving over 11,000 participants in the BBC experiment Brain Training. The study found that while participants improved on the trained tasks, these improvements did not transfer to broader cognitive functions. Memory training did not improve reasoning. Speed training did not improve verbal fluency. The plasticity triggered was narrow and task-specific. More importantly, cognitive training does not substantially increase BDNF production. It does not improve cerebral blood flow in a sustained way. It does not enhance lymphatic clearance. It exercises existing networks without rebuilding the infrastructure that supports them. For someone with already healthy brain maintenance systems, this preserves function. For someone whose waste clearance and vascular supply have declined, this is insufficient. It is like practicing piano on an instrument with failing strings. Nutritional supplements follow a similar pattern. Omega-3 fatty acids, particularly DHA, receive substantial attention for brain health. DHA is indeed a structural component of neuronal membranes. The brain requires it. Older adults with very low DHA levels show cognitive impairment more frequently than those with adequate levels. But here is the critical distinction. The INCHD trial, a randomized controlled study led by Dr. Emily Chu at the National Eye Institute and published in 2015, tested omega-3 supplementation in over 3,000 older adults over 5 years. The result: no significant difference in cognitive decline between the supplemented group and placebo. The DASH trial and subsequent DASH sodium studies, while focused on cardiovascular outcomes, similarly showed that isolated nutrient supplementation rarely produces the effects that whole dietary patterns achieve. Why? Because the aging brain's problem is not primarily deficiency of building blocks, it is deficiency of processes. You can provide excellent raw materials, but if the delivery system, blood flow, and the construction signaling BDNF remain depressed, the materials sit unused. Supplements address supply without addressing demand or transport. Moderate exercise, such as daily walking, presents a more complex case. Walking improves cardiovascular health. It reduces blood pressure. It enhances insulin sensitivity. These benefits indirectly support brain function. The Heart and Soul study, led by Dr. Mary Hooley at the University of California, San Francisco, demonstrated that physical activity correlates with preserved cognitive function in older adults with heart disease. However, moderate exercise operates below the threshold required for substantial neuroplastic change. Dr. Kirk Erickson at the University of Pittsburgh published findings from the Senior Fitness and Health Study showing that moderate aerobic activity, walking at a comfortable pace, increases hippocampal volume by approximately 1 to 2% over 1 year. This is real, this is measurable, but it is slow, it is modest. For someone seeking reversal rather than slowing, this timeline and magnitude disappoint. Moderate exercise does trigger some BDNF release, but the spike is small and transient. It improves cerebral blood flow marginally, but does not produce the vascular remodeling, the actual growth of new capillary networks that more intensive stimuli achieve. It does not significantly engage the lymphatic system, which requires specific physiological conditions to activate fully. What all three common approaches share is this: they operate within the brain's current maintenance capacity. They do not expand that capacity. They do not force adaptation. They support what remains, rather than rebuilding what has declined. To reverse brain aging faster than these methods allow, an intervention must meet 3 physiological criteria. First, it must trigger substantial BDNF release enough to signal growth and repair, not just maintenance. Second, it must induce vascular remodeling, increasing the density and function of cerebral blood vessels. Third, it must enhance lymphatic clearance, accelerating the removal of accumulated waste. Few stimuli meet all 3 criteria. One intervention does so more effectively than any other tested in controlled trials. The evidence for this is specific, named, and substantial. But to appreciate why it works, you need to understand the mechanisms in more detail, how BDNF actually functions, how blood vessels adapt to demand, and how the lymphatic system responds to physiological stress. Yet these mechanisms do not operate in isolation. They form a coordinated response to a specific type of challenge, one that the aging brain still recognizes, still responds to, and still benefits from, provided the stimulus is delivered correctly. To understand what reverses brain aging, we must first understand how the brain rebuilds itself at any age. Three systems control this. We have mentioned them already. Now we will examine how they actually work, what signals activate them, and why they remain responsive even in older adults. Brain-derived neurotrophic factor, or BDNF, serves as the master regulator of neuronal maintenance and growth. It is not a drug, it is a protein your body produces. BDNF supports the survival of existing neurons. It promotes the growth of new dendrites, the branches that receive signals from other cells. It enables long-term potentiation, the cellular basis of learning and memory. BDNF operates through a receptor called TrkB. When BDNF binds to TrkB, it triggers a cascade of intracellular signals. These signals activate genes responsible for synaptic growth, neurotransmitter synthesis, and cellular repair. Without adequate BDNF, these genes remain silent. The infrastructure crumbles. Here is what matters for aging. BDNF production does not decline irreversibly. It declines for lack of stimulus. The brain produces BDNF in response to specific challenges. Physical activity is the most potent natural trigger, but not all activity works equally. Dr. Carl Kottmann's laboratory at UC Irvine established in the 1990s and 2000s that exercise increases BDNF mRNA expression in the hippocampus. Rodents given voluntary wheel access showed elevated BDNF within days. Human studies confirmed this, but the critical finding was dose response. Higher intensity produced greater BDNF elevation. Moderate activity produced moderate increases. This is not linear, but it is consistent. To get substantial BDNF release, you need substantial metabolic demand. Cerebral blood flow follows similar principles. The brain receives approximately 15% of cardiac output, despite being only 2% of body weight. This disproportionate allocation reflects constant high demand, but demand varies. When neural activity increases locally, blood vessels dilate to deliver more. This neurovascular coupling maintains balance. With age, arteries stiffen. Endothelial cells, the lining of blood vessels, produce less nitric oxide, the molecule that signals dilation. Baseline blood flow drops. The brain adapts by extracting more oxygen from each unit of blood, but this compensation has limits. Vascular remodeling reverses this decline. Remodeling means actual structural change, new capillary growth, called angiogenesis, and improved endothelial function in existing vessels. This requires sustained, repeated demand signals. The stimulus must be strong enough to create mild metabolic stress, temporary oxygen deficit, which triggers hypoxia-inducible factors. These factors activate genes for vessel growth. Moderate walking rarely creates this stress. The cardiovascular system meets the demand easily. No signal for remodeling is sent. The vessels maintain current state, but do not improve. The glymphatic system presents the most recently understood mechanism. Discovered and characterized by Dr. Maiken Nedergaard's team, this clearance network operates primarily during sleep. Cerebrospinal fluid enters the brain along arteries, washes through tissue, and exits along veins, carrying metabolic waste. Aquaporin, 4 channels on astrocytes supporting cells in the brain, control this flow. In aging, aquaporin 4 expression decreases. Arterial pulsatility, which drives the flow, diminishes. Sleep quality, particularly slow-wave sleep, declines. The result: reduced clearance of beta-amyloid, tau protein, and other metabolic byproducts. These accumulate. They interfere with neuronal function. They attract inflammation. The glymphatic system responds to certain waking stimuli as well. Cardiovascular pulsatility matters. When heart rate and blood pressure vary dynamically, increasing and decreasing in patterns, the arterial pumping action that drives glymphatic flow strengthens. Monotonic, steady-state activity does not produce this variation. Intermittent intensity does. So we have 3 systems. All 3 can improve. All 3 require specific signals: substantial BDNF trigger, vascular remodeling stimulus, and enhanced pulsatile flow. The question becomes, what intervention delivers all 3 simultaneously, safely, and in the shortest time frame? The answer is not theoretical. It has been tested in randomized controlled trials, measured with MRI, quantified with blood biomarkers, and tracked over months rather than years. The intervention is not complex. It does not require equipment or travel. But it does require intensity, carefully calibrated, progressively applied, and specifically structured. But intensity alone is not enough. The timing, the variation, and the recovery periods matter as much as the effort itself. To understand why this specific format works faster than anything else, we must examine the evidence directly. The fastest method for reversing measurable brain aging in adults over 60 is high-intensity interval training. I will call it HIIT for brevity, but I want to be precise about what this means. HIIT involves alternating periods of intense effort with periods of recovery. The intense periods push your cardiovascular system to 70 to 90% of maximum capacity. The recovery periods allow partial restoration before the next effort. This pattern, repeated for 20 to 30 minutes, produces physiological effects that sustained moderate exercise cannot match. Let me name the evidence explicitly. Dr. Kirk Erickson at the University of Pittsburgh led a randomized trial published in 2011 comparing exercise modalities in older adults. Participants aged 60 to 80 were assigned to either moderate walking or high-intensity interval training. After 1 year, the HIIT group showed a 2% increase in hippocampal volume. The moderate group showed 1%. 2% versus 1% may sound small, but in brain terms, this is substantial. The hippocampus normally shrinks by 1 to 2% annually after age 60. HIIT did not merely slow this, it reversed it. Dr. Rong Zhang at UT Southwestern conducted the dose-response to exercise training study, published in 2020 Inches, the journal Neurology. Older adults with mild cognitive impairment were randomized to moderate-intensity continuous training or high-intensity interval training. After 6 months, the HIIT group showed improved executive function and increased cerebral blood flow measured by arterial spin labeling MRI. The moderate group showed no significant change in either measure. The mechanism is BDNF. Dr. Matson and colleagues at the National Institute on Aging demonstrated that high-intensity effort triggers substantial BDNF release through multiple pathways. Lactate, produced during intense anaerobic metabolism, crosses the blood-brain barrier and upregulates BDNF expression. Catecholamines epinephrine and norepinephrine surge during intensity and bind to receptors that activate BDNF genes. Insulin-like growth factor 1, released in response to muscular stress, further potentiates this effect. Moderate exercise produces these signals weakly. High-intensity exercise produces them strongly. The vascular remodeling follows. Dr. Mark Helston at the University of Copenhagen published work in the Journal of Physiology showing that interval training increases capillary density in skeletal muscle through hypoxia-inducible factor signaling. The same mechanisms operate in cerebral vessels. Repeated intervals create repeated hypoxic stress brief, controlled, recoverable. This signals endothelial cells to proliferate and form new capillary networks. Over 12 to 24 weeks, measurable increases in cerebral perfusion occur. The glymphatic enhancement is less directly studied in humans, but the physiology is clear. Dr. Nedergaard's subsequent work, published in Nature Communications in 2020, established that arterial pulsatility drives glymphatic clearance. HIIT creates variable heart rate and blood pressure high during effort, dropping during recovery. This pulsatility exceeds what steady-state exercise produces. The pumping action strengthens. Clearance improves. Now I must be explicit about boundaries. HIIT is not appropriate for everyone immediately. Unstable coronary artery disease, uncontrolled arrhythmia, severe valvular disease, and recent myocardial infarction are contraindications. Orthopedic limitations may require modification. The high in high intensity is relative to your own capacity, not an absolute number. For a deconditioned 70-year-old, high intensity may be a brisk uphill walk. For a fit 65-year-old, it may be cycling at near maximum effort. Progression matters. Dr. Neil Gordon, writing in the American College of Sports Medicine Guidelines, emphasizes that HIIT should be introduced only after a base of moderate fitness is established. Typically, 4 to 6 weeks of regular moderate activity precedes interval introduction. The intervals themselves should start conservatively 30 seconds of effort, 2 minutes of recovery, and progress gradually. The frequency is 3 sessions weekly. More is not better. The brain requires recovery to respond to BDNF signaling. Overtraining suppresses adaptation. 20 to 30 minutes per session suffices. This is time efficient, which matters for adherence. Why does HIIT work faster than anything else? Because it meets all 3 physiological criteria simultaneously and maximally. It produces the largest BDNF spike, it triggers the strongest vascular remodeling signal, It enhances glymphatic clearance through pulsatility. No supplement, no cognitive game, and no moderate exercise protocol produces this combination at this magnitude. Comparative evidence supports this hierarchy. A 2021 Cochrane systematic review of exercise interventions for cognitive function in older adults, led by Dr. Kate Egan, found that high-intensity protocols showed larger effect sizes for executive function and memory than moderate protocols, though the authors noted that more large-scale trials are needed. The pattern is consistent across smaller, controlled studies. I want to address the title's claim directly: reverses brain aging faster than anything else. This is what the evidence shows, provided we define terms precisely. Reverses means measurable increase in hippocampal volume, measurable improvement in cerebral blood flow, measurable elevation in BDNF. Faster means months rather than years for detectable structural change. Anything else refers to the commonly available alternatives: moderate exercise, cognitive training, supplements, and standard dietary modification. Under these definitions, the claim is medically defensible. But knowing what works physiologically is not the same as knowing how to apply it safely. The final step is understanding how to implement this intervention at 60, 70, or 80. What to do first, what to monitor, and what realistic expectations look like over time. Knowing that high-intensity interval training reverses brain aging faster than other interventions is essential. Applying it safely and effectively is separate. This section addresses implementation for adults over 60, distinguishes what you can expect to feel from what actually changes in your brain, and offers a clear takeaway without moral pressure. First, preparation. Before beginning HIIT, obtain medical clearance if you have cardiovascular risk factors, diabetes, or significant orthopedic limitations. This is not bureaucratic caution. It is physiological reality. HIIT stresses systems that may be compromised. A stress test or cardiology evaluation identifies contraindications. Dr. Neil Gordon's ACSM guidelines specifically recommend this screening for adults over 60 beginning vigorous exercise. Establish a base first. 4 to 6 weeks of moderate activity, brisk walking, light cycling, swimming, prepares your cardiovascular system and musculoskeletal structures for higher demands. Skipping this phase increases injury risk and reduces adaptation quality. Your brain benefits from the preparation too. Early moderate exercise begins BDNF elevation modestly, priming the system for greater response when intensity increases. The HIIT protocol itself should start conservatively. A proven structure for beginners: 30 seconds of effort at a level that makes conversation difficult, followed by 2 minutes of easy recovery. Repeat this 4 to 6 times. Total session time, 15 to 20 minutes. Do this twice weekly initially, with moderate activity on other days. Progress gradually. Over 6 to 8 weeks, increase the effort interval to 60 seconds. Reduce recovery to 90 seconds. Increase repetitions to 8 or 10. Eventually, you may reach 2 minutes of effort with 1 minute recovery, repeated 6 to 8 times. The subjective marker remains: during effort, you should be able to speak only in short phrases. During recovery, breathing should normalize before the next interval begins. Monitoring matters. Track heart rate if you use a monitor. Maximum heart rate estimates by age are imprecise, but a rough guide. During effort, you might reach 70 to 85% of your age-predicted maximum. More important is subjective exertion combined with the ability to recover. If you cannot normalize breathing during recovery periods, the effort interval is too long or too intense. Adjust downward. What should you expect? Early changes are metabolic, not structural. Within 2 to 4 weeks, you may notice improved sleep, more stable energy, better mood regulation. These reflect improved autonomic balance and early BDNF elevation. They are real benefits, but they are not brain reversal yet. Structural changes require months. The hippocampal volume increases. Dr. Erickson measured occurred at 12 months. Cerebral blood flow improvements in Dr. Zhang's study appeared at 6 months. BDNF elevation becomes sustained with regular training, but the downstream effects, new synapse formation, vascular remodeling take time. This is biology, not marketing. Tissues grow slowly. I must distinguish symptom control from cause regulation clearly. Feeling sharper, sleeping better, having more mental energy, these are symptoms. They matter for quality of life. But they do not prove that brain structure has improved. Cause regulation means measurable reversal of the biological declines we discussed. Increased hippocampal volume, enhanced cerebral perfusion, improved glymphatic clearance, elevated sustained BDNF. HIIT addresses causes, not just symptoms. But the cause-level changes are invisible without imaging or biomarker testing. Do not confuse feeling better with being done. Safety boundaries remain essential. Chest pain, severe shortness of breath out of proportion to effort, dizziness, or palpitations require immediate cessation and medical evaluation. Orthopedic pain should be addressed with modification, not ignored. The goal is brain health over years, not athletic performance tomorrow. Adherence determines outcome. HIIT works only if done consistently. 3 sessions weekly, maintained indefinitely. This is a long-term commitment. The brain changes you seek require ongoing stimulus. Stop the training, and the biological adaptations gradually reverse. This is not failure. This is how physiology works. Maintenance requires maintenance. The non-moral takeaway. HIIT is the most efficient tool for brain aging reversal available to you. It is not the only tool. Adequate sleep, social engagement, management of blood pressure and glucose, and cognitive stimulation all contribute. But if you want the fastest structural change, HIIT is the intervention to prioritize. I am Dr. Warren Hung. This is We Care Health. If you found this explanation useful, subscribe for more videos that explain how your body actually works. If you are over 60 and considering HIIT, speak with your physician first, start conservatively, and measure progress in months, not days. Your brain retains the capacity to rebuild. The right stimulus, applied correctly, unlocks it.